Okay, we are going to start a semi-new topic about polynomials. We're going to learn how to name them, how to add and subtract them, how to multiply, divide, etc., etc. But today is just really an intro into polynomials. And I'll explain polynomial in a second. We're actually going to start with monomial. So a monomial is a number, a variable, or a product of number and variables with whole number exponents. Okay, so this table right here shows you examples of monomials on the left and examples of things that are not monomials on the right. Okay, so again, the definition says that it could be a number. That means that this number 5 right here all by itself is a monomial. It could be a variable. That means that this x all by itself is a monomial. Or it can be a product of numbers and variables. So this whole thing right here, when it's all squished together like that, we know that that means that it's being multiplied, so it's a product of numbers and variables. So this is a monomial. Same with this guy. Okay? So now on the right side, things that are not monomials. Something is wrong with each one of these. This one, it's the -2. We said that the variables had to have whole number exponents. Well, this one does not have a whole number exponent. It has an integer exponent. Remember that negative numbers are not included in the set of whole numbers, so that one won't fly. Okay? This one is bad because it's not a product of numbers and variables. It's a difference. We can't have subtraction there. Okay? This one, same thing. This is a quotient. Something's being divided here. We can only have multiplication. Okay? Now, along those lines, look over here at letter A. This is a monomial. Okay, you'll see a few on your paper right now. What we like to do next is find the degree of a monomial. The degree is just the sum of the exponents of the variables. A constant has a degree of 0. Notice that I say variables. We are not talking about the numbers themselves, the whole numbers. We only care about the variables themselves. Okay? So if you look over at letter A, the easiest way to explain this is just to look at an example. If it's supposed to be the sum of the exponents of the variables, well, variable A, its exponent is a 2. Variable B, its exponent is a 4. The sum of that, 2 plus 4, is 6. So the degree of this should be a 6. We see the degree is 6. Okay? Letter B, which is I think number 2 on your paper, is just a 4. That's it. Well, we know that the degree is found by summing up the exponents of the variables. Well, we don't have any variables here, right? So this one, the degree is just 0 right off the bat. Degree is 0. The way they explain this is by showing that you could draw a variable on here, but in order for it to be something that would disappear anyways, you'd have to put an exponent of 0 on there. So again, it still creates a degree of 0. Third example would be 8y. Again, it's the sum of the exponents of the variables. Well, the exponent of this variable would have to be a 1. There's no other variables to add up, so our degree is just 1. Alrighty? So at this point, you have a couple more examples on your paper. So I want you to pause the video and work those few out. You are more than welcome, while this is paused, to work them out yourself and then compare answers amongst yourselves. And make sure that y'all all understand what page you should be on at this point, just understanding the degree of a monomial. So go ahead and pause the video, work those out yourselves, and then resume the video when you're ready. Okay, so at this point you should be ready to move on to talk about polynomials. So a polynomial is a monomial, or it is a sum or difference of monomials. Okay? This just means a bunch of monomials with combined with plus and minus signs. For example, that's a monomial, that's a monomial, that's a monomial. But if I do this, now it's a polynomial. Okay? So anytime you have a bunch of polynomials put together with plus and minus signs, that would be a polynomial. Okay? Or if I just erase the rest of this, you could technically call that a polynomial as well. So monomial, polynomial are sometimes synonymous, but if you have a bunch of them, then it's definitely a polynomial. And we'll talk about that a little bit more as well. So to find the degree of a polynomial, you take the degree of the term with the greatest degree. So a long time ago, we talked about terms being separated by plus and minus signs. So if I throw something back up here, I don't remember what it was originally, but let's just say it is that or something, okay? In order to find the degree of a polynomial, you find the degree of the term with the greatest degree, okay? So the degree here, we learned in the last slide, the last section, the degree here would just be 2, okay? Degree here would be 1. Degree here would be 8. That means that the degree of the entire thing is 8, okay? So let's practice on a few of these other ones. You've got some on your paper that align with what's in the PowerPoint, as well as a couple extra to practice on your own. So letter A here, which I think is your number 1, says 4x minus 18x to the 5th. Well, the degree of the first part is just 1, right? The 4 doesn't get included, so degree here is 1. Degree of the second term is just 5. So that means the degree of the whole thing is going to be 5 in general, okay? So again, they've kind of spelled this out here. The degree is 1 for the first term. Degree is 5 for the second term. So the degree of the polynomial is the greatest one, which is 5. Okay? So let's look at the next one. It's over here on the side. We need to find the degree of each term individually by adding, and then see which one is the greatest. So this one has a degree of 3, right? 2 and 1 makes 3. Degree here, these are both to the first power, so our total degree there is 2. Our degree here, we don't have any exponents, so the degree would be 0. Okay, no variables, I'm sorry, not exponents, no variables. So between the 3 of those, which one is the greatest? Well, 3. So the degree of the entire polynomial is 3. Okay, so here's one more I'll do with you, and then again I'll allow you to pause the video to work on a couple on your own. So this one, again, the degree of this guy is 4. The degree of this guy is 2. Degree here would be 1, because it's to the first power. Degree here would be 0, because it doesn't have any variables. So which one's the greatest? Well, 4, so the degree of this polynomial is 4. Okay, so at this point, pause the video and check that last one. Remember that to find the degree of each term, you add all the exponents of the variables. Ignore the coefficients, but just add the exponents of the variables. So go ahead and pause the video now, work with each other to finish out number 4 on your paper. Okay, so hopefully you are ready to go on. Now we're going to talk about the standard form of a polynomial, okay? We're actually only going to talk about this in terms of having one type of variable. It says that contains one variable, but really it's just one type of variable, like all x's all the way across, like you see up here on letter C, okay? Or all y's or something like that. So the standard form of a polynomial that contains one variable is written with the terms in order from the greatest degree to the least degree. When written in standard form, the coefficient of the first term is called the leading coefficient. Okay, I'll give you a second to kind of fill in your blanks there. When we write it in standard form, the coefficient of the first term, when it's written in order, is called the leading coefficient. Leading because it leads the pack, right? So we've got 2 examples here to kind of make this make sense. They should be on the back of your notes. So the first one, we've got 20x minus 4x cubed plus 2 minus x squared. Again, you'll notice that all we have all the way across are x's. No other variables mixed in there, okay? So if we want to write this in standard form, we need to write it so that the greatest degree comes first and then the least degree comes last, okay? So let's first just go through and find our degrees. Degree here would be 1, degree here is 3, degree here is 0, degree here is 2. So at this point, I need to write them from greatest to least, right? So the biggest one I see would be this 3 right here. So negative 4x cubed comes first. Then is the 2, so minus x squared. Then is the 1, so plus 20x. Then finally the 0, plus 2. So I have now written that in standard form so that it starts with the greatest degree and decreases from there. One thing I want to highlight before I talked about the leading coefficient is that, for example, the greatest degree was the third one right here, right? But I included that minus in front of it. Okay, you want to make sure you include the sign that comes directly in front of it. Okay, so I've written it in standard form, but now let's talk about the leading coefficient. The leading coefficient here would be the very first coefficient you see because you wrote it in order. So what's the one that leads the whole problem? Well, in this case, it'd be negative 4. So our leading coefficient, negative 4. Okay? All right, so let's do the same thing on the next one. We've got y to the third plus y to the fifth plus y to the fourth. We need to first figure out the degrees, right? So this degree would be 3, this degree would be 5, this degree would be 1. So I need to write them in order from greatest to least. So I've got y to the fifth plus y to the third plus 4y. okay? At this point, my leading coefficient is again just the one that comes first. If I write them in order, it's the one that comes first. So LC for leading coefficient. First number I see that's a coefficient, well, I don't really see one, right? So what does that mean? There's an imaginary 1. Okay, so here's 2 more to practice. I'll do these with you before I let you pause and do your own thing. So again, we need to first figure out what the degrees are, and then we will reorder, and then we will figure out the leading coefficient. Degree here is 5. Degree here is 8. Degree here is 1. Remember, there's an imaginary 1 there. Okay, so I rewrite in order from greatest to least. So negative 3y to the 8th, make sure you include that negative, plus 18y to the 5th, and then plus 14y. Okay, so my leading coefficient, again, would be the first coefficient I see because it's leading the problem, which in this case is a negative 3. Okay, now, in fact, I'm even just going to stop here. I think you can have the last one, the last 2 on your own. Work with each other and make sure that you've got it in the correct order, the correct standard form, and then pick your leading coefficient. So finish this last one that's still up here as well as the number 5 that is on your paper. Pause the video, don't forget. All right, hopefully you are ready to go on at this point. Last thing we're going to talk about is how some polynomials have special names based on their degree as well as the number of terms that they have. Okay, so let's talk about the number of terms first, which is actually on the right side of my screen over here in this table. Okay, so depending on how many terms you have, remember a term is like a section of the polynomial altogether. So if you have 1 term, it's called a monomial, right? We learned that at the beginning. So an example of a monomial would just be like 4x squared, right? That would be a monomial, okay? Now, a binomial is when you have 2 terms. Well, that would be like if I add on to it 2x, there's 2 terms. A trinomial is when you have a 3rd term, like, I don't know, 6x cubed, right? And then if you've got 4 or more, that makes it a polynomial. So if I add on to the front of this 19xy, all of a sudden now we have a polynomial, okay? So really, this just tells you how many terms you have. And you want to think about the prefixes here. Mono means 1, if you didn't know that. Bi means 2, bicycle has 2 wheels, right? Tri means 3, tricycle has 3 wheels. And then poly actually means multiple. That's why polygons have multiple sides. So again, the number of terms you have kind of determines how you name your polynomial. I do want to point out though, even if I just had 2, you could technically still call it a polynomial because it is still the sum of 2 monomials, okay? So polynomial actually, if I could adjust this definition, I would even say that it's 4 or more or even less, okay? You don't even have to have 4 or more. Any of those, all of those are polynomials. It's kind of like how quadrilateral contains both squares, rectangles, parallelograms, everything, but a square, not everything is a square, if that makes sense. So anyways, that's how you name them. Monomial has 1 term, binomial has 2, trinomial has 3, polynomial has 4, okay? That's how you name them based off of their terms. The other way to name them is based off of their degrees, which is over here on the left side of my screen. So if their degree is a 0, that means it's just a constant. That means it's just a number, right? Degree of 0 only exists when you don't have a variable at all. So for example, like the number 4, that is a degree of 0, so that's just a constant, okay? Degree of 1, that means you've got a variable, but it just has an exponent of 1, right? And that means it's linear, which you've actually already seen, right? For example, 3x. Okay, that's considered linear because it has a degree of 1. If you graphed that, it's got a slope of 3, right? Now, quadratic, that's when you have a degree of 2. An example of that would be like 4x squared, right? That has a degree of 2 because the exponent's a 2, and that would create something called a quadratic. Cubic is the last one that we're going to talk about, and that's when you have a degree of 3, so like negative 2x cubed, okay? Now, I do want to point out that just because I've only written monomials here doesn't mean that you can't have a polynomial that is quadratic, right? For example, if I gave you negative 2x squared plus 4x minus 8, We've already learned today that to find the degree of a polynomial, the degree is just the greatest one you could find, right? So the degree here is 2, degree here is 1, degree here is 0. Since 2 is the greatest, the degree of this whole thing is 2, which makes this a quadratic. Okay? So even when you have a polynomial, you still are going to look for the greatest degree you can find and name it based off of that. So let's practice just a little bit. It says, what is the name and degree? We've got 3 problems here, and you've got an extra one in your paper. So it says negative 3y to the 8th plus 18y to the 5th plus 14y. Okay? Let's figure out what the degree is first. Degree here is 8, degree here is 5, degree here is 1. So that means my greatest degree is the degree of the whole thing, which is 8. Okay? So if I was to give this a name based off its degrees, we can jump back here. Do I have one of these that goes to 8? Well, no, right? So what we're going to say, actually I don't know what I'm going to say. I'm going to pause this video and get back to you. Okay, I looked it up, no lie. I just Googled it, and it's octic, but you are never going to have to use that in this class. Okay, so just don't even worry about it, and just know that that is a degree of 8, and although it does have a special name, you are probably never, ever, ever going to have to know that. Okay? But we can name it based off of its terms, right? So it has 1, 2, 3 terms, which makes it a trinomial. That was nice and easy, right? Okay, so let's move on to the x cubed plus x squared minus x plus 2. Okay, this one, let's name the degrees, right? Our first term has a degree of 3, then we have a degree of 2, degree of 1, degree of 0. So because the greatest term, or the greatest degree is the degree for the whole thing, this has a degree of 3, which means that we would name it a cubic function, okay, because its degree is 3. Now I'm going to count how many terms I've got. I've got 1, 2, 3, 4. That makes it a polynomial. Okay? So now number 6, or not number 6, number 3, which is just 6, right? I first need to figure out the degree, right? Has a degree of 0. Well, again, if you go back to your notes, the degree of 0 means that this is just a constant. It's not really a fancy name at all. Okay? But we can name it based off of how many terms it has. We've got a whopping 1, which makes this a monomial. I do want to remind you, though, that all of these could be called polynomials, but whenever I'm looking for the correct answer on a homework or a quiz, I'm going to be looking for the most specific name you can give it, which would be monomial or trinomial, etc. Okay? So on your paper, you have one more that you can work with the group. So at this point, you actually don't have to pause the video because I'm going to end it for you. But once you work out that problem and kind of check with your peers, the sub will have homework ready for you. I'm not sure if she's going to pass it out before or after, but at this point, you'll just go on to the video. To the homework, sorry. Do the front and the back of the homework, just filling in the blanks where you can. There are quite a lot of notes provided. Feel free to read through those. It kind of says the same stuff, but it might make more sense to you hearing it in a different way. So I will see you guys tomorrow. Thank you for working hard today and being good. I hope you all have a great Wednesday.